Hey guys, good morning.
Good morning.
Good morning to the four of you. All right. Hi everyone, my name is Almog. I'm with Drivenets, and going to talk to you about what we're doing this whole week out there in the Experience Center. We have a demonstration of what we call a DDC, Disaggregated Distributed Chassis. There are actually 3 generations of DDC, all of which are on display at the Experience Center. And there are 3 companies partnering on this demonstration. That's ourselves, Drivenets, Eufy Space providing the boxes, and Credo Semiconductors providing the connectivity between all of the boxes. And like I said, all of this is on display over there. So a few words about what DDC is. Yay. That's the Drivenets perspective of this. We say that we build networks like cloud, and networks like cloud doesn't mean that the network is serving the cloud like the traditional AWS or whatever other cloud that you can think of, but the network itself is a cloud. We have devices. These devices have hardware resources. The NPU, it has all sorts of network resources. There is a CPU there, and all of this are essentially resources that then can be consumed or assigned to certain tasks. And this is exactly how our implementation of a DDC works. We call it network cloud, obviously, because it's a network that is built like a cloud. And the way it works, there is some sort of an abstraction layer on top of every hardware resources, and this creates a layer of resources which again then can be consumed by the application that is running on top. So primarily we started with an application which is a router, and this is running in production in several places, including the core network for AT&T. So this is really in production for a couple of years already. And all of this was then contributed, these definitions came from AT&T with Eufy Space and Drivenets, and made into a contribution into the OCP. So that's what's known as a DDC. Yesterday on stage we introduced DDC version 2. Okay, so there's already a version 2 of this spec. And I mentioned routing as one of the applications that can run on this, but other applications can coexist on that same infrastructure. So it can be a multitude of several routers running different purposes or different use cases of routing in one similar location. Or it can be other network functions, like there's no reason not to run a firewall on top of that same infrastructure. A firewall will then consume the same resources, be it x86 CPU cycles for compute, or network resources for bandwidth, or TCAM entries, or counters, or policers, or whatnot, other type of network resources. That's the logic of building this in a way that it's formed as a cloud. Couple of words about the formation and the logic. You can see from the attributes up above me, this is very much aligned to the tenets of OCP up until the point of sustainability, which was kind of introduced a couple of days ago as the 5th tenet for OCP. The logic is that we have taken a chassis, we stripped it apart into its basic components. So the line card of a chassis now becomes a standalone box. The fabric of a chassis becomes a standalone box. The routing engine controller of a chassis is a standalone box, or an application that runs on an x86, be it cloud or a standalone device, router, server that is located on premise. All of these components act as standalone components, and when grouped together, they all comprise of one single unified entity. The software part of this is what's coming from Drivenets that pulls all of this together into something which is unified as a single network element. So this is DDC, and then on top of this you see all sorts of applications that can run above it. Some of the applications are coming from Drivenets. Routing is the basic or classic example, but we are very much open to working with third-party providers. We are not in the business of creating the best firewall and the best DDoS and the best load balancer and the best DPI engine. We're not in that business. Expert companies are more than welcome to jump aboard. We have a dedicated API, which is open, that enables third-party applications to be mounted on top of the network cloud. that's so much for the overall solution and where Drivenets is. And from this, we'll move to look at the actual boxes. Kai from Eufy Space is going to take over.
Thank you. My name is Kai Lee. I'm with Eufy Space here in San Jose. We are headquartered in Taiwan, where our development center. So Ron from Drivenets just talked about the software component and the architecture of DDC. I'm going to talk a little bit about the building block from a hardware. So just to reiterate, DDC, distributed disaggregated chassis. So in a nutshell, what we are doing is we are taking a traditional chassis and we are breaking it down functionally by building each discrete component. So like the traditional route process on a chassis, which used to be a line card, now is the controller. Then the switching fabric is another box. The line card, 400 gig, 100 gig, those are another card. Now why are we breaking this thing down? It's really for one reason, it's for scalability. So that it's kind of like a pay as you go. You only pay for the hardware that you need, but it's designed to scale horizontally. As your network grows, you can continue to add the number of fabric and then the number of line card, and you scale them horizontally using the clocks architecture. So you will not coming up with like a chassis that, huge chassis with one line card and a giant power supply. So what we're showing here is kind of like a quick summary from the generation 1. We just presented the second generation here at OCP yesterday. So that they are based on the Broadcom architecture. The switching fabric is the Ramon, and then the line card, 100 gig, 400 gig, are based on the Jericho family. The original one, we built it on the Jericho 2. On this show, we introduced the next generation based on the J2C Plus, which brings us to a high density of 400 gig. We can support in a 2RU with dual J2C Plus, supporting up to 36 port of 400 gig in a non-blocking architecture. And this is assuming with the box. This is assuming with the box that I was talking about. On the J2C, the one thing to highlight is the Gen 1 that we introduced a few years ago was a 16 nanometer technology on the J2. The Gen 2, the J2C Plus is a 7 nanometer. So they can continue to dance the number of gates, and plus you can also expect the power consumption is much lower with some of the newer chipset. So I'm going to have Don to talk a little bit about the interconnection. Thank you, Don.
Great, thank you so much. So over at the Experience Center, we're showing 3 generations of these DDCs. The original AT&T proposal from 2020, a 96 terabit cluster that we built based on Jericho 2. You can see that one's 100 watts per 400 gig port. And the Fabric Interconnect are 400 gig AECs. You can see that one on the left over the Experience Center. In the center is the Jericho 2C Plus, the version that Kai just talked about. We get a dramatic increase in density, but I think even more important is an improvement in power efficiency. We go from 100 watts per 400 gig port to 50 watts per 400 gig port. And perhaps some of you haven't heard about Jericho 3 yet. I would encourage you to find somebody with a Broadcom shirt and ask them. However, with Jericho 3, we get a dramatic improvement in density again, as well as power efficiency, because we're moving to 100 gig lanes and because Credo introduced the 1.6 terabit OSFP XD cable at the show here. So this is the first of our terabit class active electrical cables. This product is based on our 12 nanometer Screaming Eagle product, 20 watts per end in this case. We can go 2 3/4 meters in a product that is no thicker than 2 Cat6 cables. So this allows us to interconnect that 700 terabit router that you see on the right-hand side of the Experience Center in just 3 small racks using this standard AUI interface. So thank you so much for your attention. What I would encourage you to do is either come up here and chat with us or head over to the Experience Center if you haven't been there already. Or if you find somebody with a gray Broadcom shirt, definitely ask them about their upcoming products. Thank you so much for your time and enjoy the show.